Sir, please, I sent my my assignment on the group page
Okay.
for my inverter sizing.
Okay. I will look at it now. Shortly.
Thank you, sir.
I will look at it. Okay, so let me use a whiteboard to explain what I'm trying to dish out today. So let me share my screen. Okay, so I have this whiteboard. So let's quickly look at this. Now look at the inverter. This is the inverter. The symbol for the inverter is this. You have this and you have this. Now, this is what we call direct current. Direct current or direct voltage. But this is what we are talking about, DC. This is the symbol for DC voltages. Now, or DC current as the case may be. So we have this also, which we call the alternating AC, alternating current, while DC, direct current. So this is the symbol for the inverter. Before this inverter can work, so someone designed his own system and the inverter size they came up with is 800 VA. Before this inverter can work, you need a battery. You need a battery, plus, minus. A battery has the positive terminal, it also has the negative terminal. If I'm shorting it, I just say bar 3. So this is a battery. Before this inverter can work, you need a battery. But one thing you must know is that you must know the DC voltage that this inverter is designed to work with. So what I'm saying is this. You have an inverter. 1 minute. Let me use the writer. 1 minute, please. Sorry for that. Okay, so like I'm saying, this is the inverter. This is the inverter. It has the DC side and the AC side. The inverter has a plus and minus, positive, negative, the DC input side. So you have a battery. The battery has positive, negative. In an inverter system, the polarity is very important. So you connect positive to positive and negative to negative. That is the only way by which this inverter can be powered for an all-grid system. So you have the positive, you have the negative. Someone by its design has 800 VA. This 800 VA, you must look at the data sheet or the manual of that inverter. The manual will tell you the DC input voltage of that inverter. The DC input, that means the DC voltage you can apply to this inverter before it can work. So let's say this is a 12 volt, 100 amps hour battery. C, 12 volts. If from this manual, it is stated that this inverter can work with a DC input voltage of 12 volts, that means this battery is qualified to work with this inverter. If this inverter, let's assume we have another inverter which is 1000 VA or 1000 is kilo, 1 kVA. I'm intentional in writing this K as a small letter. So imagine you have a 1 kVA inverter and the DC input voltage is 24 volts. If you have a single battery of 12 volts. So we have this inverter, 24 volts DC input voltage, 1 kVA inverter. If you take a 12 volts, 100 amps hour inverter, you know, it has a DC input voltage. So if I connect positive to positive here and negative to negative here, this inverter will not work. Because this inverter is designed to work with what? A 24 volt system. That means I am going to require two of this battery. So I'm going to have one battery, the second one, plus and minus, plus and minus. So I'm going to have 12 volts, 100 AH, 12 volts, 100 AH. This battery, for me to get 24 volts, we'll still talk about battery extensively. I will need to connect this in series. Connecting in series means connecting the negative to the positive terminal, while you have the output positive terminal and the output what? Negative terminal. So these two terminals, you will now connect to the positive of this inverter and the negative of this inverter. That means this inverter will be power on because it is designed to work with a 24 volt battery system, and you have connected the battery to form a 24 volts, 100 amp hour battery. If you connect in series, the voltage will add up 12 plus 12, 24, while the amp hour will remain the same. I hope we are following. So let me wipe this off. So this is the understanding I want you to have today. This is the understanding because it is very important, because I remember few years ago, someone was installing a system. The inverter was designed to work with 12 volts battery. And this person got two batteries. So he connected the batteries in series, which is 24 volts. But the battery, according to the specification, is designed to work with a 12 volt DC input voltage. So he connected the inverter to the battery. Guess what happened? The inverter got burnt. Because one, the inverter does not have what we call, okay, I will come to that later. But what I'm trying to say is that the battery was designed to work with 12 volts, but it connected a 24 volt system, which was more than the DC input voltage of the battery, and the inverter got spoiled. So we need to understand this so that you don't destroy the inverter you have purchased. So this is a very critical part. And most likely, we call in system design, you can refer the DC input voltage of the inverter as the system design voltage. And that is very critical. The system design voltage, because before you design any system, you need to think about it. What will be my system design voltage? My PV, my charge controller, my inverter, my battery must conform to this system design voltage when you are designing for a pulse width modulation charge controller, so to say, because I'm still going to explain what a pulse width modulation charge controller and an MPPT and the advantage of the MPPT over the PWM in your system design. So we need to know this, and it's very critical, and that is why I've explained this. So I'm going to share another screen. So this screen I'll be sharing is some of what is obtainable in the market. this is some of what is obtainable in the market. So if you go to a Nigerian market, because I'm talking about determining the system voltage. The system voltage is very important. Is the system voltage, you can take the system voltage literally as the DC input voltage of the inverter, because that tells you also how you connect your battery. So if you go to the Nigerian market or some other market, so to say, after designing your inverter and you get the appropriate kVA rating, for instance, an 800 VA inverter, you can see the DC input voltage, which I also call the system voltage to be 12 volts. If you have a 1 kVA inverter or a 1000 VA, you can also still see some of this inverter to be, that means you can see a 1 kVA inverter that has a DC input voltage of 12, or you see a 1 kVA inverter that has a DC input voltage of 24. So if you look at a 1500 VA inverter, it can also have 12 or 24. So it depends. Why 12, why 24? You may want to ask, why should you use that? If you have a 1500 VA inverter that the DC input voltage is 12, that means you can use, let's say, a single 12-volt battery and the inverter is going to work. But if you go to the market and buy a 1.5 VA inverter and it's rated for 24, you will agree with me that if you have a single 12-volt battery, it won't work for it. The minimum battery you have to buy is two 12-volt batteries, so that you can series them to give you that 24, which is the system design, which is the DC input voltage that 1.5 kVA inverter can work with. So let's look forward. You can have a 5 kVA inverter that can, mostly you will see 5 kVA inverter 48 volts. You can see some other places 5 kVA inverter 96 volts. If you have 5 kVA inverter 48 volts, that means the minimum number of batteries you can use with that inverter is how many? That is 4. 12 plus 12 plus 12, 12 plus 12, 12 times 4. That's 48. That means the minimum battery you can buy is 4. So these are the considerations you look at when you are designing your system. I'm happy now that you can all design your system. You can all design your inverter system. Somebody says, sir, please, I didn't get the MPPT and PWM inverter. No, it's not MPPT and PWM inverter. I mean MPPT and PWM charge controller. We are still going to talk about charge controller, so I will explain what these are. So I'm just telling you that in system design, there are some things you can do with MPPT that you can't do with PWM. And if you are doing big designs, I mean, into let me say, don't let me just say big design. If you are doing designs that you need to connect a lot of panels, you need to look at the best way by which you can do this so that you can work with little current. And that's the advantage the MPPT charge controller will give you. So we'll talk about that when we get there. So the inverter, and so if you have a 15 kVA inverter, for some inverter in the market, you can see a 15 kVA 48 volt Vitron inverter or Fronius, as the case may be. But if you look at this India Chinese inverter, you can see a 15 kVA inverter that the DC input voltage is 240. So what does that mean? That means you have the minimum battery you can buy before this inverter can work is how many? 20. Because 12 times 20 will give you 240. So these are the considerations you are going to look at. So when we are talking about the system voltage, it is very important. The system voltage, it is very important. So I have explained to you how you can get the system voltage. There are two ways. Number one way you can get the system voltage is to get the DC input voltage of that inverter. It's always in the manual of the inverter. And from there, you can get the DC input voltage of the inverter. So let's go to the number two way. The number two way to do this is to use the daily kVAH consumption. I mean, this is the energy, the daily energy. For instance, for some of you, if you have forgotten how we arrive at the kVAH, if I go back, so if you have forgotten how we arrive at the kVAH, I can go back. If you go back to the load audit table we did, the last column is the daily energy. So from that daily energy, we can, from the total energy that we have, we can calculate, we can use that to get the system design voltage. So so I'm going to show you that now. Okay, you have it in your Excel that we designed for the system. So let me just show you that now. Okay, 1 minute. Okay. So if you look at the Excel sheet that we did, if you look at the last column, you will see the daily energy, which is in VAH, volt ampere hour. So if you divide that by 1,000, you know how you can get with that, you can get the kVAH. So I'm trying to get the Excel. Okay. So if you can see this now, so I've explained that this column, the daily energy in VAH, you can use this value also to determine the system voltage you want to use. So let me go back to that I was sharing. So from here, we have so we've been able to explain how to use the DC input voltage of the inverter to determine your system voltage. So to use the daily energy, if your daily energy is between 0 to 4,000 watt hour or kVAH, so I can decide to change this because watt is also VA. So I can decide to use that now. So the average daily energy. So if you have 4,000 VAH, you can decide to use 12 volts as your system voltage. If your kVAH or VAH is between 4 to 6, so let's say 4,000 to 6,000 VAH, you can make use of 24 volt system. If you are between this range, make use of 48. If you are within 12 plus, you can make use of 60 plus. So this is how you determine the system voltage of your design, because this system voltage, it is very important. Okay, so I believe I've done justice to this. Let me just show you something. I want to go online. So I want to go online. Let me do from here. So I want to go to Jumia.com. Jumia is an online store in Nigeria. So I'm going to Jumia. So what I want to do is to search for an inverter. So let me search for an 800 VA inverter. Okay, so shop online. So I have 4 products. This is a Luminous Optimus 800 VA 12-volt pure sine wave inverter. So 800 VA inverter, 12 volt, what does that mean? So let me go to the specification of this inverter. The capacity of the inverter is 800 VA. That means the power factor has been included and the efficiency. The input DC voltage, that means the voltage this inverter can work with is 12. If you make use of 24, you will damage this inverter. There's a saying here that it supports 1 unit of 12-volt acid lead battery. Okay, but I say that we can still use 2 batteries. And what does that mean? That means if I have 1 battery, which is 12 volts, if I have another battery, which is 12 volts, since you have been told that the DC input voltage should be 12, then if I have 2 batteries, I believe I can use 2 units, not necessarily 1 unit. If I have 2 units, I can decide to connect these 2 units in parallel. If I connect these 2 units in parallel, my voltage will remain the same in parallel. So I still have 12 volts, plus, minus. But my amp power, let's assume this is 100 amp AH, 100 AH. If you connect batteries in parallel, the amp power will increase. 100 plus 100, that is 200. So I can still use 2 batteries. So far, it still gives me 12 volts. So I don't support this ideology that is supported. You can still use 2 units if you connect appropriately. So you have other characteristics of this inverter. So these are the vital information that you must pay attention to whenever you are trying to get an inverter system. So let's look at another inverter. Let's look at a 1000 VA inverter. 1000 VA inverter, let's see what we are going to get. I can still see 1000 VA of 12 volts. I can still see 1000 watts, 12 volts. Okay, so with minimum of 1 battery to work. Let's see a 1500 VA inverter. What we are trying to do is to see what the DC input voltage will be. Okay, so let me clean here. So I have some inverters also here. So there are different products here. You have Luminous, these are Indian inverter. You have a Schneider or Meyer inverter. So, but what I have here is 1.5 kVA 12 volts. Can you see what I was explaining to you? That means with minimum of battery, with minimum of 1 battery, this inverter will work. But look at this, 1.5 kVA 24 volts. That means this, you can't use just 1 battery, it won't work. You need at least 2 batteries minimum before this inverter can work. Same thing with this Schneider or Meyer. 1.5 kVA, how do I know? It was not written. Let me check the manual. So you click on the manual. And that is how you know. Let's click on the manual. You can see the price so that you can make some decisions. So I'm trying to look. Recommended battery size. Oh, so recommended battery size is 12 volt, 100 amp hour to 200 amp hour. But I need to know what the DC input voltage is. DC input voltage. Recommended solar panel is this 12 volt with the DC input voltage of this inverter. Okay, I can see DC output. Then I will tell you why this is different. This is an hybrid inverter. An hybrid inverter. This is an hybrid inverter. An hybrid inverter in what sense? It has an inbuilt charge controller in it. It has an inbuilt charge controller. So what this means is that you can connect your solar PV directly to the terminals at the back of this inverter, and the charge controller is inside. That's just it. That's why it's called the hybrid inverter. Okay, so I'm not getting a lot of information with regards to, but I see a recommended battery size. Yes, that's the recommended battery size, but I'm not saying the DC input voltage. So, one is 1.5 kVA. AC DC output is what I'm saying. Recommended battery, yes, I see the recommended battery to be 12 volt 100, but what is the DC input voltage of this inverter? This is a great information that I think is missing here. Yeah, so let's look at one more inverter. You can see this one, 1.5 kVA 24, 1.5 kVA 12, 1.5 kVA 24. So let's check a 5,000 VA inverter. What the DC input voltage would be. Okay, so look at this. 5 kVA, 48 volt. That means the DC input voltage is 48. The minimum number of batteries you can use for a 12 volt battery is 4. If you use 3, it won't work. If you use 2, it won't work. You need to get 4. But this is another 5 kVA, but this can use 24 volt. That means you can use 2 batteries for this, but the minimum you can use for this is 4. So this is what you need to understand when it comes to inverter selection with respect to the DC input voltage, which also gives you pre-informed decision on the system design voltage that you need to use. Okay, if there's any question, please kindly drop your question. So let's look at one more thing that I would like to explain. Okay, so when you are using inverter, you have different types of inverter in the market with respect to the output waveform. The output waveform. So there are 3 most important ones. You have the square wave, you have the modified sine wave, and you have the pure sine wave. So imagine you have from this origin, you have this. So if you have a waveform like this is an alternating current. This is exactly how the supply from your utility, your distribution companies look like. So this is an AC alternating current, AC current, and this is a pure sine wave. This is a pure sine wave. So, but imagine that you have a square sine wave. So see a square sine wave in this form, a square sine wave. So a square sine wave, if you have an inverter that is square sine wave, this will be one of the cheapest in the market, but it is used for some of the simplest appliances that you need to use, because it is not the best of what you need to use in terms of the output waveform. The modified is in between the square wave and the pure sine wave. So the modified, you can have the modified in this form, the modified. So, but if you look at the pure sine wave, this is what is similar to what the electricity company sends to you. So it is always good to go for an inverter that is pure sine wave, but the thing is the cost will be higher than that for the modified sine wave. The cost for the modified sine wave is cheaper than the pure sine wave. For modified, if you use modified sine wave, if you use it to power some inductive loads like that, like maybe your standing fan, you may be hearing some, uncomfortable sounds because it is not working with the equipment excellently. If you have sensitive devices like electronic devices that require pure waveform, the pure sine wave would be the best for you to use. So I recommend for you pure sine wave inverter for all your system installation. Okay, so any question? Any question? Do we have one or two things to ask? Okay, so any question?
Hello, sir.
Yeah, I'm with you.
Okay. Let me give an example. If I have a 12 volts, 1000 amps hour inverter.
No, VA.
So that means the
a 12 volts,
volts,
1000 VA or 1 kVA inverter, not amps hour.
1 kVA inverter.
Yeah.
Is it compulsory that it is 12 volts I will use, or I can use above 12 volts for the input? Is it that particular 12 volts, or is just minimum of 12 volts I can use as the input?
So the DC input voltage to the inverter, where did you get, will you get it from? You are going to get that from the battery. And you have different types of battery. You have 6-volt battery, you have 4-volt battery. The most common is the 12-volt battery for this kind of application. So you will need to use a 12-volt battery. The 12-volt battery can be 100 amp hour, can be 200 Ah, but ensure that it is 12 volt. So for an inverter that the manufacturer says the DC input voltage is 12, that means the minimum battery you can use is 1, which is 12 volt. You can use 2, but that will now lead us to how to connect batteries in series and parallel, which we are still going to talk about. So, but you must ensure that the total DC voltage that you are putting on the terminals of the DC input of the inverter must be 12. If not, if it's more than 12, you damage the inverter. Any question again?
Thank you very much, sir.
Okay. Okay, so with this, we are going to stop today. So when next we meet, we have done and discussed everything about inverters. So if you have further questions, you can drop it. So everything we need to know about inverter, we have discussed. So in the next class, we'll move to another part of the inverter solar system component. Remember, I said we have the inverter, we have the solar panel, we have the charge controller, we have the battery. So we are done with inverter. If you have any other question, you can drop it, then we'll talk about it.